Okay, we are going to be looking at the standard deviation and the 68, whoops, let me write that, 68, 95, 99, that's a dash, 99.7 rule. Okay, what this looks like always, it's always this. You got your little bell curve thing here, right? In the middle is your mean. One standard deviation away. What this tells us, this rule, is that 68% of the people are going to fall within one standard deviation of the mean. So that's this middle section right here, total 68. What that means is that each one of these totals 60 or 34 because 68 divided by 2, they're shared, right? So then I go to one more standard deviation over. Okay, those 95% of the population falls in that, in 95. I mean, in those two, within two standard deviations. So how I can figure this out on my map is I go 95 minus 68, because I've already got this number in here. That leaves me with 27, and I'm going to divide that by 2. Okay, so this gives me 13.5 right here. Whoops. That was weird. My little guy's not working. 13.5 and 13.5. Okay, then I go, my next standard deviation out is 99.7. Okay, so that's this big thing right here. Whoops, I should use a different color, but anyway. So we're going to do the same thing here. We're going to go 99.7, subtract all of this stuff, which was 95%, right? That leaves me with 4.7 divided by 2 leaves me with 2.35 in this little thing right here. And then I can see that if I wanted 100%, it would be 100 minus 99.7. That equals 0.3, and I'm going to divide that by 2. And that is 0.15. So almost no one is in this little section up here that's, I'm not going to write it in there because it won't fit. Okay, it's a very small section of the people. So every time I have a standard deviation thing, I use this chart. It's always the same. These numbers are the same every single time. So if you have one of these and you just draw it up every single time, or you just have one maybe in pen and you write your answers here or down here in pencil that apply to that problem, then you can do any problem with this. So I'm going to just do, it's an example 5 in chapter 6, 6C, that is on page 388 in your textbook. This is about, so the survey finds the prices paid for 2-year-old Ford Fusion cars are normally distributed with a mean of 17,500. It's going to be kind of hard. 17,500 and a standard deviation of 500. So I'm going to have to write these down here because, so that's 18,000. This one's going to be 18,500. I should have made this fatter, huh? This one's going to be 19,000, right? Then I come over here. This one is going to be 17,000. This one's going to be 16,500. And this one's going to be 1,600. Or 1,000, sorry. Okay, so the first question it asks me is it wants to know how many people paid between 17,000 and 18,000. So I can look here and I can see between 17,000 and 18,000 is 68%. Okay, it's 34 plus 34 between 17 and 18, right? 34 plus 34. I'll draw those down there so you can see. So that's 68%. And it told me that 10,000 people, the story said 10,000 people bought cars. So I can just use my calculator and go 68%. Whoops, I didn't get my decimal in there. 68% of 10,000. And that is 6,800. So my first answer for how many people, whoops, that's an A, 6,800. Okay, because it was 68%. Then the next one, it says remaining 32%. Oh, no, sorry. How many people paid less than 17,000? So I go to my 17,000 and I'm looking for everyone that's less than this. guess what? All I have to do is add up those percentages. 13.5 plus 2.35 plus 0.15. And that is 16. So that's 16%. So I'm going to go 0.16 times 10,000. And I'm going to get 1,600. Okay. And then the last question they asked is how many people paid more than 19,000? More than 19,000 is just this little section right here, 0.15. Okay, and so if I can find my calculator, there it goes. It's 0.15% times 10,000. And that's, whoops, I think I did, sorry, it's 0.15%, so it'd be 0.0015 times 10,000. 15 people. Okay, so be careful of that when you're dealing with these small ones, that you move your decimal 2 full places. So this one would be 0.0235. Anyway, and this one 0.0015 because I already have decimal. So that's basically how you do any one of these standard deviation problems. I don't bother with the calculating the math every single time. I do it once right here for this little table, and then it's always the same. And then my numbers, it's just a matter of adding up the percents and then applying it. Sometimes I even want to know just what the percentage, you don't even have to, the percentage is, you don't have to apply it to any number. So hopefully that helps.